Continuing with the arithmetic group of instructions of Intel 8085 microprocessor, we have done 16 instructions so far, and in this lecture we'll be doing 4 more instructions. The last 4 are somewhat a little bit different from the first 16, so uh, they have been segregated separately. Now these instructions are, first instruction is that's the instruction number 17. So this instruction is INXRB. Now, similar to what INXR does, this increments the contents of the register pair now by 1 instead of the register here. We have the register pair and its contents are increased by 1. So in the macro arterial can be written as RP is equal to RP plus 1. The other properties of this instruction are it's a single byte instruction and it has only one machine cycle, that's the opcode fetch machine cycle. The difference here is that the opcode fetch machine cycle will not have 4 T states, but it will have 6 T states, and therefore the execution time will be 1.92 microseconds. The number of variations of this instruction are 4. You have INX B, INX D, INX H, and INX stack pointer. No flags are affected by this instruction. The addressing mode, since the register pair is involved, so source and destination both register addressing mode. As far as the micro RTL of the instruction goes, we have the output fetch machine cycle having 6 T states. The first 4 T states are same. In the fourth T state, INXRP becomes equal to 1. In fifth and sixth T state, this instruction, unlike other internal instructions of the microprocessor, does not take 4 T states to complete. It will take 6 integral time cycles to complete. And therefore, in the fifth and sixth cycle, RP becomes equal to RP plus 1. Next instruction that we have is Dcxrb, similar to INXRB. It decrements the contents of the register pair by 1. So therefore, we can write the macro RTL of this instruction as RP is equal to RP minus 1. The other properties of this system are similar to that of INXRB. It's a single byte instruction. It has only one machine cycle, that is the opcode fetch machine cycle, having 6 T states, and therefore an execution time of 1.92 microseconds. The variations, there are 4 variations. These are DCXB, D, DCXH, DCXSB. No flags are affected by INX and DCX instructions. The addressing mode is register addressing mode. A micro RTL of this instruction again is similar to what we saw in case of INX RP. T5 and T6 will be of integral, it will take integral time cycles for this instruction to execute completely. Now instruction number 19 is DADRP. Now this is somewhat different. In this instruction, the contents of the register pair are added to the contents of the register pair HL, and the result is then placed in the register pair HL only. So we can write the macro RTL as HL is equal to RP plus HL, or we can also write this as L is equal to LP plus least significant bit of RP, and H is equal to IH plus RP, the most significant bit plus the carry. It again is a single byte instruction. The opcode only consumes 1 byte of space. It has 3 machine cycles: the opcode fetch machine cycle, bus idle machine cycle, and bus idle machine cycle. So the number of T states will be 4 plus 3 plus 3 equal to 10. Execution time will be therefore 3.2 microseconds. It will have 4 variations, just like INX. These will be DADB, DADD, DADH, and DADSB. Only affects the carry flag, no other flag will be affected by this instruction. Addressing mode, for the source it will be register, and the destination is implied because it is implied that the output will be placed in the HL. Micro RTL of this instruction, you have a similar code fetch machine cycle, you the usual T4 4T state code fetch machine cycle. Bus idle machine cycle, you have two bus idle machine cycles, 1 and 2. In the first one, you have they are both similar in T1 and T2 states. What will happen is that the address bus, the data bus, and the control bus, they will be actually idle. And in T3 state of the first machine cycle, L will be incremented and it will generate a carry. But in bus idle machine cycle 2, H will be incremented and it will be added with the carry generated by the L in the first bus idle machine cycle 1. Instruction number 20 is DA. It's simply DA. What happens with this instruction is that an 8-bit number, that's actually in the accumulator, it's a binary number. From that, we will be forming two 4-bit BCD numbers. You have studied BCD numbers, they are 4-bit numbers. And if in case the MSB or the LSB of that BCD number is greater than 9, then 6 will be added. So you can see the macro RTL, A of binary is converted to A of BCD. It's a simple instruction. Rest of the properties will be same. Single byte instruction, one machine cycle, that is only the opcode fetch machine cycle. And in this case, the opcode fetch machine cycle is the usual 4T state, consists of 4T states. Therefore, the execution time will be 1.28 microseconds. The variations will be, there are no variations, it exists only as DA. There is nothing associated with this instruction. It affects all the flags because the accumulator is involved here, so the flags are affected. The addressing mode, for the source it is implied. There is no destination exactly in this, and we do not mention the destination for this case. You have the normal opcode fetch machine cycle for this instruction, no difference here. So this actually completes our arithmetic group of instructions. We have listed all the 20 instructions in the arithmetic group. Following this, we'll be doing the logical group of instructions. Again, the logical group of instructions, like the arithmetic group of instructions, hit the clocks. They are a part of the ALU operations of the microprocessor, and you'll see almost similarity between the arithmetic group of instructions and the logical group of instructions. So we'll start with them in the next session.